Every single day, over 2 billion cups of instant coffee are consumed worldwide. That's 23,000 cups every second. You've probably had one this week, maybe this morning. You watch those granules dissolve in seconds and think nothing of it. But here's what you don't see: a flower that blooms for only 3 days. A race against time measured in hours, not days. Machines that can't quite do it alone. And humans with a superpower that no AI can replicate. What seems instant took a journey across 3 continents that most people never imagine. This is how instant coffee is really made. The origin. Let's start with a number that puts everything into perspective. Over 60% of the world's coffee comes from just 2 countries, Brazil and Vietnam. We're talking about hundreds of thousands of farmers working every single day, producing millions of bags of beans annually, and the scale. It's almost incomprehensible, but here's what most people never think about. Your instant coffee, the one you make without a second thought. It began its life as something incredibly delicate, fragile even. Coffee plants produce these small, fragrant white flowers, clusters of them. Beautiful, right? But they only last 2 to 3 days. Think about that. 72 hours, then they're gone forever. Over the next 6 to 9 months, if everything goes right, those flowers transform into vibrant red cherries. 6 to 9 months of waiting, of monitoring, of hoping the weather cooperates. And inside each cherry, the precious coffee bean you'll eventually drink. But here's where it gets tricky. These farmers can't just pick whenever they feel like it. They have to harvest when exactly 95% of the cherries have turned that deep, perfect red. Not 90%, not 100%, 95%. Too early? You get sour, underdeveloped flavors, acidic in all the wrong ways. Too late, overripe, fermented, unpleasant tastes that ruin the entire batch. Timing is absolutely everything. On smaller farms, this is still done entirely by hand. 1 cherry at a time. Experienced pickers can collect maybe 100 to 200 pounds per day. That's it, a full day's work under the sun for 200 pounds. But on large-scale operations, they bring in the machines. And that's where this story really gets interesting. The imperfect machine. Picture this massive machine rolling through coffee plantations. It's equipped with hundreds, sometimes thousands, of vibrating rods mounted on rotating cylinders. Each rod vibrates rapidly, up to 1,000 times per minute. As it passes through the coffee plants, those rapid vibrations cause most of the ripe cherries to fall into collection trays below. The machine spends just 2 to 3 seconds on each tree. Move in, shake, collect, move on. One machine can collect what would take a team of workers days to finish by hand. In about 5 hours, a single harvester can gather dozens of bags of cherries. That's the efficiency. That's the scale modern coffee production demand. But here's the thing no one tells you. These machines aren't perfect. Sure, they get most of the ripe cherries, the 95% that need to be picked, but some unripe ones fall too. Some overripe, some leaves, some stems, even small branches sometimes. The machine doesn't have eyes. It can't make judgment calls. It can't match the precision of an experienced human hand that knows exactly which cherry to pick and which to leave for another day. And that's exactly why what comes next is so crucial, because the moment those cherries are picked, a clock starts ticking. 8 to 12 hours. That's all the time they have before natural fermentation begins breaking down the sugars inside, before the flavor profile starts to degrade, before everything the farmer worked months to grow gets ruined. It's a race against time, and losing means destroying an entire harvest. The cherries rush to the wet mill, conveyor belts moving constantly. Every minute counts now. The wet mill. Welcome to the wet mill. This is where coffee cherries begin their transformation from fruit into something you'd recognize as coffee, and this is where the harvest gets saved. First stop, the gravity separator. It's one of those solutions that's brilliantly simple once you see it. A massive tank filled with water. The ripe cherries, dense and heavy, full of developed sugars and oils. They sink straight to the bottom. The unripe ones, light, hollow. They float to the top like corks. This is where the harvest gets perfected, where the machine's mistakes get caught and corrected. Those unripe cherries that shouldn't have fallen, separated here, removed. But here's what genuinely surprised me when I learned this. Those rejected cherries don't just get thrown away, they're repurposed, turned into fertilizer, sometimes even biofuel. Nothing is wasted in this process. Every part of the cherry finds a purpose. The good cherries move to depulping machines. These have rotating drums lined with textured surfaces. They gently press the cherries against fixed plates. The pressure is calibrated perfectly, enough to strip away the outer pulp, but not enough to damage the precious beans inside. That stripped pulp also turned into nutrient-rich compost, fed back to the soil for future crops. It's a closed loop, sustainable by design. Now, here's a number that genuinely shocked me when I first learned it. Roughly 5 kilograms of fresh coffee cherries produces only 1 kilogram of green coffee beans. 5 to 1. That's an 80% loss, just to reveal the bean inside, and we're not even close to instant coffee yet. Not even halfway through the journey. After depulping, the beans are left with this sticky coating called mucilage. It's slimy, translucent, and it has to come off, but carefully, very carefully, because one wrong move here, and you ruin the flavor profile of beans that took 9 months to grow. Tension build. In traditional settings, those beans go into fermentation tanks filled with clean mountain water. Sometimes these are ceramic lined, kept at specific temperatures. For 12 to 24 hours, natural enzymes in the water break down that slimy mucilage layer. It's a biological process, ancient, used for centuries. Farmers monitor constantly, checking by hand, feeling the texture between their fingers, because here's the risk that keeps them awake at night. Too little fermentation, the mucilage won't come off cleanly. You'll have residue. It affects the taste. Too much, the beans develop sour, unpleasant flavors. Acetic acid builds up. One mistake, one batch left in too long, one miscalculation, and you've ruined everything. Months of work gone. In modern factories, they've automated this delicate dance. Massive stainless steel tanks, high-pressure water systems, digital sensors tracking pH levels, temperature, and time in real time. Automated agitators stir the beans at precise intervals. It's the same fundamental process, the same biological breakdown, just with precision and consistency that human monitoring alone can't match. No guesswork, no risk. After fermentation, the beans get washed, sometimes multiple times. In traditional methods, workers use long wooden tools to stir vigorously, scrubbing away the sticky residue. The water turns murky, clouded with dissolved mucilage. They drain it, add fresh water, repeat until the water runs clear, until the beans are spotless. Then comes the drying phase, and this is where patience becomes essential. Traditionally, beans are spread across massive drying beds, sometimes concrete surfaces, sometimes raised mesh platforms. Farmers use rakes to turn them throughout the day, every few hours, ensuring they dry evenly, preventing mold, preventing any section from retaining too much moisture. It takes 1 to 2 weeks, depending on weather conditions, on humidity levels, on how much sun they get. The target, exactly 11% moisture content, not 10%, not 12%, 11. In factories, industrial dryers compress that timeline dramatically. Hot air circulated through rotating drums, temperature and humidity monitored by the second. What takes weeks in the sun gets accomplished in a few hours inside these machines. Same 11% target, but total consistency. No weather delays, no waiting. When the beans reach that perfect dryness, they pass through hulling machines. The tough parchment layer that's protected them throughout drying gets stripped away, and finally you see them. Vibrant green coffee beans, the color of jade. Each bag you see in a warehouse represents months of work, the coordination of dozens of people, perfect timing at every single step. But we're still only at green beans. The journey's not even close to finished. Now those beans are about to enter a world of precision engineering that turns agriculture into science. The factory. Hundreds of trucks arrive at major instant coffee facilities every single day, each one loaded with those carefully processed green beans. Those 60-kilogram bags, about 130 pounds each. They're lifted by specialized robotic arms equipped with multi-point vacuum grippers. Multiple suction points create a secure hold across the bag's surface. One bag every 15 to 20 seconds. These robots work 24 hours a day, 7 days a week. No fatigue, no breaks, no injury risk. For decades, lifting these bags was done by hand. Back injuries were common. Chronic pain was expected. Now, the robots handle the physical toll. As bags move along extended conveyor systems, they pass through multiple automated checkpoints, each one testing, verifying, ensuring quality. Near-infrared scanners measure moisture content through the bag material itself. No need to open it. The technology reads right through the jute. Remember that 11% target we talked about? The tolerance here is plus or minus 0.5%. 0.5%, even slight deviation, the bag gets automatically diverted off the main line. Rejected, sent for reprocessing or evaluation. Quality control is absolute. Robotic sampling probes extract small samples of beans as bags pass by. These needle-like devices penetrate the bag and withdraw just enough for testing. Those samples go immediately to quality control laboratories. Chemical analysis for caffeine content, acidity levels, any potential contaminants. Everything gets tested before beans are approved for production. Approved bags meet another set of robotic arms that stack them onto pallets. The robots calculate optimal stacking patterns, maximum stability, perfect weight distribution. It's engineering and mathematics applied to something as simple as stacking bags. But here's where it gets really interesting, where despite all this automation, all these robots, all this cutting-edge technology, humans remain absolutely essential. The human element. In this age of automation and artificial intelligence, there's one aspect of coffee production that remains irreplaceably human: taste. Meet the coffee tasters, professional cupping specialists, the unsung heroes of the instant coffee world. These people taste between 80 and 100 coffee samples every single day. 80 to 100 samples. They can detect subtle variations in acidity, in body, in aroma compounds most people can't even perceive. They can identify the geographic origin of beans with remarkable accuracy. Brazil versus Vietnam, highland versus lowland, even specific regions within countries. Their palates, refined through years of daily practice, a skill that can't be programmed, can't be replicated by sensors. The ritual is strict, almost ceremonial, controlled temperature, precise humidity levels, consistent lighting. Many facilities start cupping sessions first thing in the morning, when palates are most sensitive before any external factors interfere with judgment. Tasters avoid perfumes and colognes. No strongly scented soaps, no spicy foods for at least 12 hours before tasting. Some avoid alcohol for days before critical evaluations. Every variable that could interfere, eliminated. The protocol is precise. Ground coffee gets inspected first for color consistency. For aroma intensity, then hot water at around 93 degrees Celsius gets poured over the grounds. It steeps for several minutes. Then they break the crust. Using a cupping spoon, they push through the layer of grounds floating on top. That releases a concentrated burst of aroma, the first indicator of quality. After cooling slightly, the real tasting begins. And yes, the slurping you see, that's required technique. It's not poor manners, it's physics. Slurping sprays the liquid across all taste receptors, aerates it, allows them to evaluate the coffee's mouthfeel, its finish, its complexity. They evaluate multiple criteria: fragrance and aroma intensity, flavor clarity and complexity, acidity balance, body weight and texture, sweetness levels, the aftertaste duration and quality. Each sample gets scored on a 100-point scale. And here's the standard: only coffees scoring 80 or above get approved for instant coffee production. Anything below, rejected. One bad bean in a batch can ruin an entire cup, and no machine, no matter how sophisticated, no algorithm, no sensor array can replicate the complexity of trained human taste buds interpreting flavor. So even in a factory run by robots, monitored by computers, automated at every possible step, the humans remain the final gatekeepers, the last line of quality control, irreplaceable. The roast and brew. Approved beans move to industrial sifting machines, removing any remaining debris or broken beans. Then comes roasting. The beans are fed into massive double-walled rotating drums. These are heated to temperatures between 190 and 280 degrees Celsius. Inside, specially designed paddles keep the beans in constant motion. This ensures even roasting, prevents scorching. The roasting time? Anywhere from 8 to 20 minutes. It depends entirely on the desired flavor profile. Lighter roasts retain bright acidic flavors and slightly higher caffeine content. Darker roasts develop bolder, more robust notes with slightly less caffeine. Though the difference is smaller than most people think, when the beans hit that perfect roast level, they're immediately dumped into large cooling trays. Powerful fans and mechanical stirring arms cool them in 5 to 10 minutes. This stops the roasting process instantly, locks in the precise flavor profile. The cooled beans get ground into coarse powder and brewed using steam and high pressure in massive stainless steel tanks. This creates an incredibly concentrated liquid coffee extract, thick, almost syrupy. And here's another number: roughly 2 kilograms of roasted beans produce about 1 kilogram of instant coffee. Do the math. Total loss from cherry to final instant coffee product? Around 90%. 9 out of every 10 kilograms gone. The fork. Path A. spray drying. This is for regular instant coffee granules. The concentrated liquid extract gets forced through high-pressure nozzles at the top of massive towers. These atomizers turn it into millions of microscopic coffee droplets, a fine mist suspended in air. Simultaneously, scorching hot air at around 540 degrees Celsius blasts through. It instantly evaporates all moisture from those tiny droplets. The water turns to steam, vanishes. But then there's path B, freeze drying. The extract gets carefully heated and reduced through controlled evaporation. It becomes thick, viscous, almost toffee-like. Then it enters a lengthy freezing tunnel, sometimes 30 meters or more. Temperatures inside plummet to around -50 degrees Celsius. It emerges as a solid sheet of dark coffee ice. Rotating blades break that frozen sheet into small, irregular granules. Those frozen granules get placed into low-pressure vacuum chambers. The pressure drops significantly. Then they're heated to around 60 degrees Celsius for approximately 5 hours. What's left? Perfectly dry coffee granules with a porous, honeycomb-like structure. The choice between spray and freeze drying. It's a choice between speed and perfection. Either path leads to the same finale. So the next time you're tired, stressed, in a hurry, and you reach for that jar of instant coffee, scoop those granules, watch them dissolve. Think about this journey. It started with a flower that blooms for only 3 days. It traveled through the hands of hundreds of thousands of farmers working across continents. It survived an 8-hour deadline, a race against natural decomposition. It passed through machines that couldn't quite do it perfectly alone. It sat in fermentation tanks where one mistake could ruin months of work. It faced human tasters who rejected anything scoring below 80, lost around 90% of its original weight. It split into 2 paths, one taking seconds, one taking hours, all to end up dissolving in your cup in seconds. What seems instant took an entire global supply chain working in perfect harmony. And maybe, just maybe, that's worth slowing down to appreciate, even if it only takes seconds to make.